In this video, we are going to see the next chapter in chemistry, that is Unit 10, S block elements. And in this video, we are going to study about Group 1 elements. S block elements. Now, what are S block elements? They are the elements of group number 1 and group number 2. And why are they called S block elements? Because the last electron enters into S orbital. So, they are called S block elements. Now, let us see which are the group 1 elements. So, we have group 1. And group 1 elements are also called alkali metals. Now, why are group 1 elements called alkali metals? Because they form hydroxides with water which are alkaline in nature. So, they are called alkali metals. Now, let us see which are the group 1 elements. The group 1 elements are lithium, sodium, potassium, rubidium, cesium and francium, out of which francium is the radioactive element. Now, what is the general electronic configuration of group 1 elements? The general electronic configuration is noble gas NS1. NS1 is the valence electron and there is only one valence electron present in group 1. Now, N is the period number. Period number for lithium. Lithium is N is equal to 2. Sodium is 3, 4, 5, 6 and 7th period we have francium. Now, let us write the electronic configuration of these elements. Lithium takes the noble gas configuration of helium. I will write the noble gases first: helium, neon, argon, krypton, xenon and radon. Now, helium, lithium configuration will be helium 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. So, this is the electronic configuration of group 1 elements. Now, next let us study the properties of group 1 elements, and that we will discuss as question answer model. Now, the question is, all the group 1 elements are the most electropositive element in the periodic table. We know that the general electronic configuration of group 1 element is NS1. So, they have only one electron in the valence shell which can be removed easily. So, that valence electron is loosely held by the nucleus. So, it can be easily removed and one electron is lost, resulting in M plus ion, that is a cation is formed. So, we can say group 1 elements are electropositive in nature. Now, alkali metals are never found in free state in nature because they can readily lose one valence electron to form M plus ion. So, alkali metals are never found in free state in nature. Now, the next question, when we move from lithium to cesium, atomic or ionic radii increases. Lithium to cesium means down the group, the atomic radii increases. Now, what is the reason for that decrease in atomic radii? We know that down the group N value increases. So, force of attraction between the electron and nucleus decreases. But down the group atomic number increases, so nuclear charge increases. Also, when you move down the group, there is screening effect, and that increase in screening effect is more than the increase in nuclear charge. So, what happens? Z effective decreases and the size increases. Okay. Now, next is give two uses of sodium and lithium. Now, what are the uses of sodium and lithium? Now, sodium lead alloy, lead is Pb. Sodium lead alloys, they are used as anti-knock additives. Anti-knock additives in petrol, and liquid sodium metal is used as a coolant in nuclear reactor. Now next is the use of lithium. Lithium lead alloy. So lithium lead alloy that is used to make white metal bearings for motor engines, and lithium aluminum alloy. Lithium aluminum alloy is used to make aircraft parts. And we have the use of cesium also. What is the use of cesium? Cesium is used in photoelectric cells. Now, photoelectric cells means cells that convert light energy into electrical energy. So, cesium is used in photoelectric cells. Now, the next question is, the ionization enthalpy of group 1 elements are low compared to other group elements in the periodic table. Now, we know that in the periodic table, the ionization enthalpy is the lowest for group 1 elements. Why? Because we know that the group 1 elements electronic configuration is noble gas NS1. So, there is only one valence electron which when removed will lead to stable noble gas configuration. So, the ionization enthalpy of group 1 element is very low. Now, the next question is, lithium salts are mostly hydrated among alkali metals. So, if you take the alkali metals, that is group 1 metals, the lithium salts are mostly hydrated. Hydrated means they are always with water molecules, and this lithium salt, lithium chloride will exist as LiCl.2H2O, means that lithium chloride is associated with 2 water molecules. Now, what is the answer for this? Smaller the size of the ion, higher the hydration enthalpy. So, this is a very important sentence, that is, smaller the size of ion, higher the hydration enthalpy is denoted as delta H HYD. This is hydration enthalpy. So, this is a very important sentence. Smaller the size of the ion, higher the hydration enthalpy. So, we know that lithium ion, that is Li plus, has the smallest size among group 1 ion. So, it forms the most hydrated salts. And when you arrange the ions in decreasing order of their hydration enthalpy, we have first Li plus greater than Na plus greater than K plus greater than rubidium plus greater than Cs plus. So, lithium salts are mostly hydrated because lithium ions are smaller in size, and smaller the size of the ion, greater is the hydration enthalpy. Hydration enthalpy means the energy required for the ion to form a bond with water molecule, or the energy released when a bond is formed between the ion and the water molecule, that is hydration enthalpy. Now, the next question is, metallic character increases down the group. We know that in group 1 elements, francium is highly metallic in character, or it is the most electropositive element in the periodic table. Now, what is the reason? Because down the group atomic size increases, ionization enthalpy decreases, so it readily loses electron and metallic character increases. Now, next question is, alkali metals have low melting point and boiling point because of weak metallic bonding due to the presence of single valence electron in them. So, these alkali metals, they have very low melting and boiling point due to weak metallic bonding. Weak metallic bonding, and that weak metallic bonding is due to the presence of single valence electron, and cesium has the lowest melting point among the alkali metals. Now, the next question is a very important question. Alkali metals and their salts impart characteristic color to the flame, or alkali metals can be detected by flame test, or lithium salts impart crimson red, sodium salts impart yellow, potassium salt impart violet color to the flame. Why? Now, the answer is, when you heat these salts of alkali metals, the heat from the flame excites the valence electron to a higher energy level, and when they come back to the ground state, that is low energy level, there is emission of radiation in visible region and exhibit color. So, that is the answer for the color of flame for alkali metals and their salts. Now, the next question is, cesium and potassium are used as electrodes. Electrodes. You have learned about the two electrodes used in electrolysis, anode and cathode. So, cesium and potassium can be used as electrodes in photoelectric cells. The answer is, due to large size and low ionization enthalpy, they can eject the electrons when they are exposed to light. That is, they can exhibit photoelectric effect. Now, next question is, give the reaction of alkali metals with oxygen. We know that the alkali metals combine with oxygen to form oxides, and lithium when treated with oxygen forms lithium monoxide, and the formula is Li2O. Now, sodium when treated with oxygen forms peroxide, and the formula of sodium peroxide is Na2O2. And potassium, rubidium, cesium and francium, when treated with oxygen, they form superoxides. Superoxides have the general formula MO2. For example, potassium oxide, KO2. The formula is KO2. So, different types of oxides are formed by alkali metals. Lithium forms monoxide, sodium forms peroxide, and the other elements form superoxides. Now, here potassium oxide, that is KO2. KO2 is paramagnetic in nature. Now, the answer is, it is paramagnetic because the superoxide, that is O2 minus ion, is paramagnetic because of one unpaired electron in the pi star 2p molecular orbital. So, this KO2 is paramagnetic due to the presence of unpaired electron in pi star 2p molecular orbital of O2 minus ion. Now, the next question is, alkali metals are normally kept in kerosene oil because of their high reactivity towards air and water. They are kept in kerosene oil. Next is, alkali metals tarnish in dry air. Tarnish. Why alkali metals tarnish in dry air? It is due to the formation of their oxides on the surface on reaction with air. Now, next question is, although lithium has the most negative E0 value. Negative E0 value. Now, E0 means standard electrode potential value. These values you get from electrochemical series, which we will learn later. So, it is said that lithium has the most negative E0 value. We have E0 value positive as well as negative. Now, in the electrochemical series, lithium has the most negative E0 value. Its reaction with water is less vigorous than that of sodium. Why? This is due to small size of lithium ion, Li+. It has very high hydration enthalpy and it forms hydrated salts. Now, next question. Lithium fluoride is almost insoluble in water. So, lithium fluoride is insoluble in water, whereas lithium chloride is soluble in water as well as in acetone. Acetone is an organic compound, organic solvent. Now, what is the answer for this? This answer is based on Fajan's rule. Now, you know that according to Fajan's rule, smaller the size of cation and larger the size of anion, higher the polarization and more covalent is the compound. So here, when you take lithium fluoride and lithium chloride, lithium ion is smaller in size and Cl minus ion is larger in size than F minus. So, Li plus can easily polarize Cl minus ion than F minus, and therefore lithium chloride is more covalent and hence more soluble in water and acetone than lithium fluoride. Now next question, group 1 metals are obtained by chemical reduction methods. Because this group 1 metals, they are very strong reducing agents. Reducing agents, they help in reduction and they get oxidized. So this group 1 elements, they are very good reducing agents and they can undergo oxidation easily by losing electron. We know that reduction means gain of electron and oxidation is loss of electron. So group 1 elements are very good reducing agents, so they undergo oxidation easily by losing electron. Now next question, what happens when sodium metal is dropped in water? So we will write the equation when sodium metal is dropped in water. Sodium metal 2Na plus 2H2O. The product formed is sodium hydroxide plus hydrogen gas. So what is evolved when sodium metal is dropped in water? Hydrogen gas is evolved. Now the second question, when sodium metal is heated in free supply of air, we know that sodium when treated with oxygen, sodium peroxide is formed. Let's write the equation for that. 2Na plus O2 gives Na2O2. Now the next question is, sodium peroxide is dissolved in water. What happens? So let's write the equation. Sodium peroxide Na2O2 plus 2H2O. You get the product as sodium hydroxide plus H2O2. H2O2 is called hydrogen peroxide. So sodium peroxide when added to water, we get hydrogen peroxide. Now the next question is, lithium is the only alkali metal which form nitride directly. Nitride. How is a nitride formed? By treatment with nitrogen gas, we get nitride. Now lithium when treated directly with nitrogen, we get the nitride of lithium. What is the answer? It is due to diagonal relationship of lithium and magnesium. Lithium and magnesium. Since magnesium can form nitride directly, lithium since it shows a diagonal relationship with magnesium also can form nitride directly, while the other elements cannot. Now let's write the equation for the formation of nitride. Lithium plus 2N gives 2Li3N, lithium nitride. This is lithium nitride, Li3N. Now you know the valency of nitrogen is 3. So it is written under lithium, and valency of lithium is 1, written under nitrogen. Now the next question, the mobilities of alkali metal ions in aqueous solution. Mobilities means movement. The mobilities of alkali metal ions in aqueous solution is Li plus less than Na plus less than potassium, rubidium ion less than cesium ion. Now why is the order like this? The mobilities of alkali metal ions in solution is the lowest for lithium ion and greatest for cesium ion. What is the reason? We know that lithium ion is smaller in size, so high hydration enthalpy and lesser is the mobility. So smaller the size of the ion, higher the hydration enthalpy and lesser is the mobility. So Li plus has smaller size and lesser mobility. Now the next question, what are oxo acids? Give example. Oxo acids. Now, oxoacids means they are compounds in which acidic proton on hydroxyl group. Hydroxyl group is OH group. So this proton means H plus, is acidic in nature. And one oxo group. Oxo group is double bond O attached to same atom. So oxoacid, how will you identify an oxoacid? If in the structure we have one acidic proton on hydroxyl group and also one oxo group, that is double bond O attached to the same atom, we can call that compound an oxoacid. For example, sulfuric acid is an oxoacid of sulfur. Sulfuric acid formula is H2SO4. Let us draw the structure of sulfuric acid. Sulfur is the central atom, double bond O, OH, OH. So this is an oxoacid because we have two acidic protons on hydroxyl group. Also we have there are two oxo groups. It's not one, but oxoacid means at least one is enough. One oxo group and one acidic proton. Now here we have two oxo group and two acidic proton on hydroxyl group. So sulfuric acid is a oxo acid. Now the next question is, we know that the first element of each group will show anomalous properties. So the question is, give reason for anomalous properties of lithium. Anomalous properties of lithium. Lithium is the first element of group 1. Now, what are the reasons for the anomalous properties? Small size, large charge by radius ratio, absence of d orbital, and the maximum covalency is 4. So, these are the 4 reasons for the anomalous properties of lithium. Now, next let us see the points of difference between lithium and other alkali metals. How lithium shows differences in properties from other alkali metals. Now, the points of difference between lithium and other alkali metals. The first point is lithium is much harder. Its melting point and boiling point are higher than those of other alkali metals. Second point, lithium is least reactive but the strongest reducing agent among all the alkali metals. On combustion it forms mainly monoxide and the nitrite, Li3N, unlike other alkali metals. Third point is lithium chloride is deliquescent. And crystallizes as a hydrate, LiCl.2H2O, whereas other alkali metal chlorides do not form hydrates. So lithium chloride is deliquescent. Now the next fourth difference is lithium hydrogen carbonate is not obtained in the solid form while all other elements form solid hydrogen carbonates. Next difference, lithium unlike other alkali metals form no ethanide on reaction with ethine. Ethine is an alkyne, so lithium cannot form ethanide with ethine, whereas other alkali metals can form ethanide with ethine. Now the last difference is lithium nitrate when heated gives lithium oxide, whereas other alkali metal nitrates decompose to give the corresponding nitrite. So lithium nitrate, the formula is LiNO3. On heating we get lithium monoxide plus nitrogen dioxide plus oxygen gas, whereas other nitrates, group 1 nitrate, sodium nitrate will decompose to give sodium nitrite, NaNO2 plus oxygen gas. This is sodium nitrite, NaNO2, ITE, and this is sodium nitrate, NaNO3 is ATE. This is ITE. Okay. Now the last is lithium fluoride and lithium oxide are comparatively much less soluble in water than the corresponding compounds of other alkali metals. So we have total 7 points of difference between lithium and other alkali metals. Now the next question is, lithium iodide is the most covalent, Li is the most covalent among all alkali metal halides? Now the answer is, you know that among the halides, I minus has the largest size and Li plus has the smallest size. So Li plus can easily polarize I minus, therefore LiI, lithium iodide, is the most covalent in nature. Now the next question, why lithium shows similarities to magnesium? You know, magnesium is in group 2. And the answer is due to diagonal relationship, which is due to similarity in ionic size and charge by radius ratio of elements. So the reason for diagonal relationship is due to same size and also same charge by radius ratio. Now the next question, that is the last question, is the points of similarities between lithium and magnesium. So what are the points of similarities between lithium and magnesium? Similarities between lithium and magnesium. Lithium and magnesium, they show diagonal relationship. So the properties exhibited by lithium and magnesium will be the same. Now what are the similarities? The first one is both lithium and magnesium are harder and lighter than other elements in the respective group. Second point, lithium and magnesium react slowly with water. Their oxides and hydroxides are much less soluble and their hydroxides decompose on heating. Both form nitride by direct combination with nitrogen. Now lithium forms lithium nitride with the formula Li3n and magnesium forms Mg3n2 because the valency of magnesium is 2. Now third point of similarity is the oxides, lithium oxide and magnesium oxide, do not combine with excess oxygen to give any superoxide. Now the next point is the carbonates of lithium and magnesium decompose easily on heating to form the oxides and carbon dioxide. Solid bicarbonates are not formed by lithium and magnesium. Fifth point, both lithium chloride and magnesium chloride are soluble in ethanol. Ethanol is alcohol. And the last point, both lithium chloride and magnesium chloride are deliquescent and crystallize from aqueous solution as hydrates. Lithium will crystallize out as lithium chloride 2H2O and magnesium will crystallize as magnesium chloride dot 8H2O. So these are the points of similarities between lithium and magnesium. And with this we complete the properties of group 1 elements of S block. Thank you.